Hello everyone, my name is Dhruv Khirsariya. I am from CSPIT CSC, Charotar University. Today I will be presenting on a very exciting and fantastic topic, neuromorphic computing with digital logic. This topic combines two powerful concepts, the way our human brain works and how we can replace that using digital logic and circuit. Throughout this presentation, we will be explore how neuromorphic systems are designed and how they are different from traditional computing and how digital logic play a key role in making this possible. So let's bring our journey into the future of artificial intelligence. Understanding neuromorphic computing. Neuromorphic computing is inspired by the structure and function of the human brain. It trained to mimic how our brain works using neural network for more efficient computation. Unlike a traditional system, this is a completely new way to process information. Many institutes like Stanford is actively research on this key concept of neuromorphic computing. It mirrors the brain structure and uses neural networks to replace brain-like functionality. This brings a big shift from traditional computing, make it faster, smarter, and more energy efficiency. Importance of neuromorphic computing. The technology is important because it offers 10 times more efficiency and then use much less power, making it perfect for all devices and smart systems. Its global economy impact also huge. It could reach up 411 billion dollars. What is digital logic? Now let's understanding digital logic. Digital logic is the base of all modern computers. It uses a binary number like 0 and 1, analog with logic gate and Boolean algebra to perform operation. This is a very different from neuromorphic computing, which behave more like analog system. Digital logic in neuromorphic computing. Digital logic is still important in a neuromorphic computing. It helps a concept traditional computing with a brain like a model. Using a logic circuit, we can mimic the way neurons connect and communication. Basic concept of neurons and synapses. In our brain, neurons send signal and synapses are the connection that help learning. One key learning method is STDP, which help the brain adapt. Neuromorphic systems are inspired by this to building smarter hardware. How neuromorphic chips work. Neuromorphic chips work differently. They are event driven, meaning they respond only when they need. They are parallel processing built in memory and can learn in real time. Hardware used in neuromorphic computing. Those systems need a special hardware such as memory store and novel materials. They often use a mix of analog and digital precision. Popular tech include the silicon-based circuit. Digital logic's role in neuromorphic chips. Digital logic still plays a major role. It helps in implementing neural network algorithms, make the chips configurable and adaptable. It brings the gap between brain-inspired learning and computer logic. Key features of neuromorphic computing. Let's now take a look at some of the key features that make neuromorphic computing stand out. Firstly, low power consumption. Low power consumption since neuromorphic chips are event driven, they are energy only when required. Second, massive parallel processing. Just like the human brain, where multiple neurons work together at the same time. And lastly, they have an adaptive system, thought model inspired by how the brain learn, like STDP. Those features make a neuromorphic system highly stable for AI, robotic, and real-time activities. Neuromorphic computing, revolutionizing computational programs. Neuromorphic computing isn't just improvement, it's a paradigm shift. It's changing the way we think about computational, moving away from traditional step-by-step processing to a model that biological, inspired, and adaptive and efficient. This bond of digital logic and brain like a learning could revolutionizing field like autonomous vehicles, IoT, healthcare, and even space technology. Traditional versus neuromorphic computing. Let's compare traditional computing with neuromorphic computing. Traditional computing system use the VON Newman model, where memory and process unit are separate. This case delay known as the VON Newman bottleneck. Neuromorphic systems are completely different. They are event-driven support and parallel computational and less power, up to 1000 times less in some cases. This makes the ideal for real-time energy efficient applications like variable touch, robotic and brain computer infrastructure. Digital logic circuit in neuromorphic chips. Even though the neuromorphic computing in brain-inspired digital logic still plays a huge role. Logic circuits are used to create a speaking neural network or SNNs. Those mimic how biological neurons fire. Neuromorphic chips also use adaptive weight to stimulate learning and which add randoms just like the human brains inspired. So while the system is inspired by biology, it's built using the tools of digital electronics. How neuromorphic computing is constructed. Neuromorphic systems are built using artificial neurons that work similarly to digital logic units. Those neurons communicate using speak or pulse, not continuous signals. The system is designed to learn through algorithms like STDP, where the timing of skip decide how the system adapts. The combinational of digital logics and brain like a model create a machine that can think, learn, and even more decision. Key application of neuromorphic computing. For example, in the AI, where low power in a critical in a robotic, it help real-time decision making. It also used in a pattern recognition, like face or speech detection, and in a smart sensor for healthcare and industrial system. All of those benefits from neuromorphic system being energy efficiency and fast learning. Companies pioneering neuromorphic technology. Many big tech companies are investing in this field. Intel has developed for a low chip, which is one of the most advanced neuromorphic processing today. IBM built the Truth Notes chip, which simulate millions of neurons and billions of snaps. Even Google is researching neuromorphic method to improve AI performance. Those inventions are pushing neuromorphic computing into real world using caches. Advantages of neuromorphic computing. There are many advantages of neuromorphic computing. It use very low energy, so it's perfect for battery operated and remote devices. It provides a high speed processing escapability for tasking innovation processing like image and sound recognition. It can self-learn, reducing the need for manual programming, and it work will in a real time, adapting instantly to new data. Those benefits make it ideal for next-gen smart system. Challenges in neuromorphic computing. Of course, there are still some challenges. one of the main issues for the complexity of algorithms. Neuromorphic systems are difficult to program and design. The cost development is also high since the hardware and tools are still new, and limited scalability is co- building a large scale system that work like a full brain in a still a big task. Despite this research in moving fast and solutions are improving. Future outlook 90% in a potential integration with quantum computing. Second, 25% expanded AI and machine learning application. 75% in a breakthrough in EDG computing. Conclusion. In a conclusion, neuromorphic computing is a revolution step in a technology. It blends a biology and digital system to create a smarter, faster, and more efficient machines. With more research and innovation, it could transform how we interact with AI in future. Thank you so much for your listening to my presentation. I hope you understand this topic like neuromorphic computing with digital logic. This topic saw how computers can work like the human brain. It helps the machine to learn, think, and very less power. We also saw where the technology is used, like robotics, math system, and machine learning and used for future computers. Yes, there is are some problems like high cost and it hard to build, but in the future it will come better and more useful.